Hi, welcome to Azure User Group Sweden. Welcome, everybody. I see that we have already some friends joining us on the live stream right away. Thank you for joining us and happy Saturday. Hi, Håkan. Happy Saturday. And
Yeah, hi
you?
Jonah. Happy Saturday to you too.
Yes, yes. How are you doing today since the last live stream?
Yeah, I'm doing pretty fine. It's maybe -8, -10, and actually quite a lot of snow outside.
Same here. I think we have about -6 or -8 also today, and lots of snow outside. So I had a morning walk with my dog and appreciated the winter. At the same time, also a bit cold. So it's good to be warm indoors and learning something new today through our user group. So those that are watching us today, I know a few friends like Kim Berg. I know he's joining another MVPs and want to learn with us today. Welcome and thank you for joining us. And if you are watching this recorded, feel free to scan where or toggle wherever you want to go watch the session. But we are actually having issues with the live stream we scheduled on LinkedIn just for everyone who really tried to watch the session on LinkedIn. But during the session, I will try to re-add so we can repost the live stream to those that wanna watch this. But we have a special topic today and a guest joining us far away from Sweden, of course. But I'll let Håkan introduce him. Before we do that, let me introduce Håkan to first timers. I want to introduce ourselves. So Håkan, my co-leader, Håkan Silvernagel, is from Norway. He is also Microsoft MVP for AI. He is a community leader at Norwegian.net user group, leader at the AI 42 school. He's a Microsoft certified trainer and also a community lead like me. And I am very happy and honored to have him as my collaborator and co-host of co-organizer of this user group for the past like four years. So it's amazing, and I'm glad you're still here, Håkan, helping me. Thank you.
Yeah, thank you, Jonah. It's a real honor and pleasure here to be part of this. So I'm very happy to introduce Jonah Andersson. She's the founder of our user group. She is an Azure MVP and also an MCT, Microsoft Certified Trainer. And she is also a public speaker, a podcast host, and author for learning Microsoft Azure on O'Reilly. And she works as a senior Azure consultant.
Yes, thank you, Håkan, for the introduction. Let me just show everyone our code of conduct before we kick off. So we are part of Azure Tech Groups in Sweden, and we host our sessions virtually for free for everybody, for the community. And we follow a code of conduct where we expect everyone to be respectful and inclusive in interactions, comments, and questions that you may have during our live stream chat or even our after session fika that we usually have as a virtual private meetings with us and the speaker. And speaking of fika, the virtual way, we're gonna use the same link, Bitly link, Azure Sweden dash fika 2026. After the session, when we get off here, then we're gonna have a private Zoom where you can continue our chat and questions with us and together with the speaker if you have anything important you want to discuss. Okay. Is it time, Håkan?
Yes, so we are very proud here to be able to welcome our speaker, Fisnik Doko. Welcome, Fisnik.
Thank you. Thank you. And it's a pleasure to be here together with you.
Yes, welcome.
So a little bit more formal introduction here to Fisnik. So Fisnik is a senior Azure AI and cloud architect and also a Microsoft certified trainer with a deep experience in building production-ready AI system using Azure AI Foundry, Azure OpenAI, multi-agent architectures, and secure cloud-native platforms. And he has more than 35 Microsoft certification, and he also has a PhD in data science. And he spent more than a decade helping enterprises modernize with AI distributed system and cloud governance. So we're very happy to have you here with us, Fisnik. What
Thank you.
will you present here to our viewers today?
Thank you. As a first, yes, I am more than 11 years as a Microsoft trainer, delivering workshops around the world, and more than 17 years in the industry. In the last 3 years, since the start of Azure OpenAI service, I have started with that, with workshops, consultancy, with projects, and until now, during this contact in conferences, in events, I have seen that we have something big, something perfect like Microsoft Foundry, but the issues and those, let's say, not obstacles, but the not doing by best practices start from earlier in the phase, and then later we have some issues. That's why today we are going somehow back to the let's say beginning of an idea of an agentic AI, to be there as much as possible, let's say more comfortable, more tested, and then when we go into cloud or in production, then to be more productive, more effective, and those smaller things to be fixed earlier, to be those challenges again, everything to be isolated earlier, and then with more success will go towards the production. Okay, then we can start with the
Yeah,
presentation part.
interesting. Yeah, that's great. I look forward to learn from you. And I know there are many attendees. I announced this just like just this week, but we have 35 attendees that signed up, and 19 of them are actually attending for the first time. Thanks to your network, also Fisnik, and our community members. But thank you. So let's go ahead and show the presentation and kickstart.
Thank you. Yes,
See
then
you.
I see the presentation. It's about building an agentic AI locally using Azure AI Toolkit extension in Visual Studio Code. As we mentioned, we have powerful platforms. We have powerful platforms like Microsoft Foundry, but what we see also, according to Gartner, according to other sources and to reality, to the contacts that we have, that not all projects, not all AI projects, they don't go all of them in production. They struggle. Why? Because of issues like unclear agent behavior, like a lack of evaluation, poor observability, and then teams realize too late that they don't have the trust in what they have built in, or that solution is not ready for that enterprise company or organization or let's say industry, and that's why everything goes back. In other words, the platforms like Foundry, they solve deployment, scaling, governance, but they don't fix problems that originate during experimentation. And if agent logic is fragile, if prompts aren't tested, or if the tool usage isn't controlled, these problems simply get promoted to the cloud later, and then will be too late to fix or will be more costly. Also, many developers, they struggle like, I don't have an Azure account, I don't have access to models, all that, and like I am blocked to start with this agentic AI. And today we will see that even for free, just having Visual Studio Code, just having a GitHub account, we can do that experimentation, we can do that, we can test that idea, we can evaluate, we can trace, we can connect with MCP servers, and then when locally will be ready, then we can continue with the next stages for deployment to cloud. For that purpose, today in the following for around 45 minutes, we will go through this structure session. First, here we will start with the AI shift and why agentic AI matters. This is like the setting the context, like where we are, what is going. Then we look about what an agent really is, just shortly, and very important, like why building agents in code and while building locally, which is important, and we'll compare like while to do that. And then we will continue with the tool chain in Visual Studio Code, including GitHub Models, AI Toolkit, and how other tools fit there. We can mention that Microsoft Foundry extension there. Then we will see in demonstration how these parts looks, how these functionalities are there. We will touch them. And then finally, we will see what are the, let's say, next steps, or how to move from local to cloud using this toolchain, this environment that we mentioned here. First, AI is reshaping our world, and that's not in years, not in months, but it's happening right now. And what used to require a specialist teams or long development cycles, now that is going just very fast, within hours, within minutes. And now the future is not a trend, but it's a present reality. Like never before, things are going very fast, and we live, let's say, in reality now, which is driven by AI. Second, making the impossible possible. As AI has moved beyond just the text generation, we now have systems that can understand language, images, also tasks that were previously too expensive or too slow or too complex now can be automated suddenly. And also going back in these 3 years, we started just with LLMs, like question answering. Then we continued with RAG, with some custom RAGs. We continued with agents, agentic AI. The things moved too fast. And now we have even autonomous things that can create a lot of things for us. And the third pillar, which is shown also here, is that AI is redefining enterprise capability, and that organizations are no longer looking at AI as a cost center or as experimentation, but it's becoming now a strategic driver, or a way to move faster, to make better decisions, and also to build capabilities that weren't feasible before. What we see a shift that doesn't come from models alone, but it comes from how we design, we build and operate AI systems, and with that we get the benefits to stay ahead of, let's say, competitors, and to make our life easier. For the last few years, a lot of AI work was in pilot projects, proofing concepts, but that phase is ending. And according to Gartner, by 2028, more than 95% of enterprises will have used generative AI APIs, models, or will have deployed Gen AI enabled applications in production. If we compare 1 year ago, like more than 50% of those pilot projects were not going to production. But what we see that the near future, it's the opposite. This also tells something critical, that we are not anymore in experimental AI. Like it's becoming part of core business systems. And also we see that 50% of enterprises by 2027 will use a generative AI to launch agentic AI pilots. Also, there is an important nuance here, that many organizations start agentic pilots. Far fewer will successfully scale them, and the gap between the pilot and the production is where the most teams struggle. That is also the reason that we mentioned in the beginning, and that happens due to complexity, governance, lack of engineering discipline. And this is exactly why local first agentic development it matters. Like if AI is already in production, then agents need to be built like a real software, tested, evaluated, governed, and not treated like experiments. And that is the aim today, that we will try in local environment to imitate all this. We have an important slide in front of us, like agentic AI development challenges. And according to statistics from last year, that over 70% of generative AI experiments never make it to production. And most of them don't fail because the model is bad. They fail because the surrounding system isn't ready. First, it's about the model selection and deployment. Like there are thousands of models, and the teams struggle to decide which one to use. For this purpose now in Foundry, we have there the leaderboard we have the benchmarks, the comparison. It helps a lot, but also in Visual Studio Code, we can get such help. Another reason is the complex workflows. As soon as you move beyond a single prompt, then you introduce multi-step logic, tool calls, and also branching paths, and this complexity can become also unmanageable. Another blocker, especially for compliant industries, is the content safety. Like once agent starts acting autonomously, you need guardrails, you need predictable outputs, you need to take care which informations can be used, which are classified, for which part of the team are classified, labeled, etc. Another blocker, especially for industries like banking, healthcare, those which are stricter, is the observability and governance. Like if the team introduces them too late, then they can realize there are some gaps in the audits, and without tracing, debugging, this cannot go in production. And another challenge that developers face, it's also the tool sprawl. Like agents start calling many tools, APIs, often without clear boundaries of ownership, and this then increases the risk of like making systems harder to reason about, and that's why everything of these challenges we can deal locally even today, and then reducing the risks that we mentioned here. Just a quick recap about the AI agents here. What we see that at top here we have inputs, which can be a user question, event, or trigger from another system. And that important part is that input doesn't directly go to a model, it goes to an agent, which agent is like orchestrator. It's responsible for designing what to do with the input, how to respond internally. And then we have here, starting from the LLMs, like the reasoning engine, swapping different models here depending on the need, local models, cloud models. Then we have instructions where we define the behaviors. These are very important, and even the tool today will see like it can help, can improve our instructions, can generate instructions to be more detailed. And the third here, we have the tools, like connecting the agent with tools to be able for real capabilities, like to retrieve data, to retrieve data from other systems, and to allow some memory to retain a context across interactions. And these are the parts that work together inside an agent, and this make that, let's say, the magic to happen. Also, the agents had evolution in this last 1 or more than 1 year about agents. Starting with one agents, it was all single. Then we continued with multiple agents. We also here see different symbolized AI tools interacting with real world. We have AI services we can connect, like searching, vision, language models. And then in the multi-agent steps, we can connect these. We have a multiple SDKs, tools that make it work. I will not go deeper there. We also have triggers that connect agents to events. Also, we have a human in the loop, where it's must in many of the solutions, someone to validate, to check, or to approve those actions. And this shows that Agentic AI is not just a single model or a prompt, but it's a system of agents, tools, services that are working together. And what we are building locally is ability to design and test such system safely before we scale to cloud and before we go to the next stages. Why to build agents in code? Probably, I'm sure that most of you already have built agents through Copilot Studio, through other tools, even through Foundry, just with drag and drop, with some clicks. That's okay, but those are treated like low-code tools. We have like low-code tools and pro-code tools, where in pro-code we have a total ownership of the code and full control through the code. If we build agents in the code, we have a full control, customization, and then we can use any model, we can use more connectors, and we control how the agent reasons, when it uses tools, how outputs are structured, and we have control in lower level, which is essential once agent starts operating in real workflows. The second as shown here is about a local experimentation. And when agents are built in code, we can run them directly in the laptop. We can use the tools like Visual Studio Code, GitHub. We can debug step by step in Visual Studio Code. We can test. We can integrate in the CI/CD pipelines, easier this with code. And all this happens in a local environment or even before going to cloud deployments, which very important, it shortens the feedback loop. We get immediately those, let's say, feedbacks or results or issues we face in the local machine. And the third reason is the portability. Like once we have code first agents, we can move from local development to any cloud, or even making them as container images. And with that, we have flexibility to not be a vendor lock and to make less architectural, let's say, changes later. Like low code tools, the ones that I mentioned in the beginning, are great for quick demos or for trying an idea to check how that looks, or to show to someone a POC. But if you want agents that are testable, debuggable, and production ready, then the code is the choice. It gives the foundation and makes, let's say, more stable, more controlled for the future. The next slide here, it answers a simple question, like why build agentic systems locally in the first place? First, the hello world demos don't scale. And the single prompt that looks impressive in isolation usually fails apart the moment that you introduce tools or multiple steps or real users. Like most failures happen after the demo stage. Second, agent needs iteration, not infrastructure. It means needs a version, designing, changing prompts, tools, logic, and if every change required a cloud setup, credentials, deployments, it will slow down dramatically. Then another key point is evaluate before you deploy. Like agent quality isn't about how impressive one response looks, it's about consistency. And when being in local or local workflows, it lets testing agents against data sets, comparing version, catching regressions earlier. Additionally, we do all this with no cost, like we do locally in our computers, no infrastructure to provision, no API keys to be managed, no cloud cost. We just focus on the logic, on the code, and we don't have a disturbance that is out of our primary idea. Like when we do such systems, we want the logic to be functional. That's why this local development, it enables that. Once we have the idea that is working, then normally we can easier than deploy go to cloud. And all this that we speak is not anti-cloud. It's just making stable things and then moving happier to cloud. Moving happier, we'll see even here with GitHub Copilot. It can do a lot of stuff to move our simple idea that we built with confidence locally to move easier all that in the cloud. Before we touch any tooling, let's just be aligned on these core concepts, that the agent is not a chat application, and the chat app answers once, forgets. Here on the other side, agent operates in a loop. It plans, take actions, and then also observe results. Additionally, Tools are first-class citizens. It means that real agents don't rely on model and knowledge alone. They read files, they can query systems, can run scripts, and without tools, agents are just smarter chatbots. Also, we aim for determinism over vibes. In production, we care less about poetic answers and more about structured, predictable outputs, which are also traceable, observable. Additionally, evaluation, it's not optional anymore. Like if you can't measure whether one version of your agent is better than another, then nothing. That is the reason here that local evaluation lets catch such failures earlier. And traceability, it becomes here from the early days. We can include just with some common traceability. We can see the traces even local in Visual Studio Code. And then we are more covered for going in the next stages. Because without traces, debugging agents, it's impossible. And these are the concepts that we'll go through the next minutes here. Before we open the tools, we'll start with GitHub Models. This is where experimentation happens. Like we have access to a curated catalog of models. We have access to prompts, playgrounds. We can access these GitHub models through the direct URL through the browser, but we also have integrated them in the Visual Studio Code through the AI Toolkit extension. We will mostly use now in the following minutes the AI Toolkit for Visual Studio Code. This is a developer experience layer inside Visual Studio Code, which brings together GitHub models, local models, ONNX models, MCP tools, also Foundry. Everything will be just in Visual Studio Code, and we don't need to switch different browser tools. And having all this locally, we will not have that, let's say, spending time on such disturbance or switching contexts. And then when we will be ready to move to production or to a higher environment than experimentation, then we can use the Microsoft Foundry extension. It is again in Visual Studio Code. It is very similar with the AI Toolkit, but is strictly directed for using the Foundry projects through the portal, but also we can do everything and from here in the Visual Studio Code. We have here the AI Toolkit. AI Toolkit, who should use or what's the primary audience? Starting from developers can use to experiment with models, also to integrate AI into their applications, to connect those. AI engineers can use data scientists to test models, to evaluate, to iterate agents locally. Also, researchers, educators can use this controlled environment to explore more without requiring any complexity for infrastructure. Additionally, some key use cases is very often used and for running using local models. Additionally, for converting, optimizing models through this tool, even fine-tuning we can do with the help of this tool. And all this, it starts with the extension that is here, AI Toolkit for Visual Studio Code. This is the main extension, and after you install the extension, it will be shown here as a AI Toolkit. This is the primary tool. Despite the AI Toolkit, in extensions, we can search for Microsoft Foundry. There is another extension, Microsoft Foundry, and with this extension from Visual Studio Code, again, we manage most of the things that we can do in the Microsoft Foundry portal, and then we can have the both extensions here installed in our Visual Studio Code. In the first look, they look very similar, where in the AI Toolkit we have more options. These are the the mandatory tools, we have here again the AI Toolkit listing some of the features, the most primary, where everything starts with the model catalog. This is where we explore models and then we use them in the playground. We have playground even in Visual Studio Code, despite in the AI portal. We test prompts, we adjust parameters, we understand their behavior, and very ideal for experimentation and for hypothesis testing. Once we are ready, then we can go with the next part here for the agent builder. This is where prompts become agents with instructions, tools, structure output, and is the bridge between experimentation and real systems. Additionally, we have bulk run, a model evaluation, which are about reliability. And instead of testing one input at a time, here we can run agent against data sets, measure quality consistently, and we can compare normally the versions. We have more advanced scenarios here, like fine-tuning and model conversion, which allow to adapt models or optimize them for specific environment, including local execution. We have the possibility for tracing to give a visibility into agent behavior. We have a tracing even in the AI Foundry, but here we have it just in our tool here. And we have the options for profiling with Windows ML, which helps to understand performance characteristics when running models locally, which especially matters for real-world applications. Together, these features here allow complete local development workflow from exploration to agent construction, connecting with MCP tools, evaluation, tracing, and then being ready for going into production. Just briefly here about capabilities that we mentioned, like here in the prompting, we can chain prompts together about multi-step workflow. In the MCP tools, we can here dynamically invoke tools. We have some tools already here publicly connected to Visual Studio Code, but additionally, we can create our MCP server very easier with the help of the tool here, which guides with a new project and everything. Then the testing, evaluation, debugging, we can do here the agents, we can start in debugging mode, even we can start the MCP servers in debugging mode in parallel, having local tracing and introducing here tool calls, decisions, which are critical for debugging complex behaviors. And then once ready, here we have the help of Copilot agent that can help us to go to production, like helping even with Azure commands, with architecture. If you are a developer not familiar with Azure things, then there is a lot of help based by best practices to continue with all this. What we will see also in the following minutes is that GitHub Copilot agent mode is integrated, and now a lot of help for defining agents, even for agents, enabling evaluations, tracing. It all can be done by the agent mode here. Additionally, you have an existing application, you have now agents, concatenating them or integrating them through the help of agent mode can be done with a lot of success. And despite doing the things, it can explain to us, it can ask us for the next steps. Okay, here, let me jump to the tool and let me see here more in the tool. Starting here, first again, we are in the AI Toolkit, and we have here many features, or the features that we mentioned. Going first to the models. What we see in the models, we see that I already have connected there some models. We can add models. Those models can be Ollama models, can be add Foundry local model, like we can select one and then we can get locally. We get also their size, we get their definitions, CPU, GPU, all those things. Additionally, here in models, we can add a custom model, but that custom model needs to be OpenAI compatible, and we have those definitions. But for models, we can start easier here with the model catalog. We have here the model catalog, where we have some popular models, and then we have some filtering by who is hosted, a publisher, feature, if we want for text, if we want for image, models, like I want local models which are with CPU, we get a list here, and even models for fine-tune support, we can enable and that option. And coming back, we see a lot of models. Let me just ask here a model, GPT-5. We can see here many models like hosted by Foundry, and then we see also GitHub models. For this case, let me choose GPT-5 Mini. If I click this model, it will load the model card. The model card gives here the details about the model. We can add the model. I will click add. And in GitHub here in models is added that model. I can also add in the nano version, adding. It also appeared in the nano version. Additionally, we have the option to try in playground. Everything happens here. We have now a drop down where we can select the model. Like we can see, these are GitHub models, local model, and even remote models from Foundry. Let me go with GitHub models. I can choose GPT-5 Mini. And additionally, we have here compare. Like we can do comparison side by side. For this purpose, I will choose even GPT-5 Nano via GitHub. We have a 2, and we can just ask here. I will travel to Stockholm. Recommend me places to visit. As you see, I'm writing on the left side automatically. It wrote in both sides. We can compare side by side here immediately, and we can see that even the latency, we can see down the right is still generating nano. We can see the type, and we can do here the first. We can do the, let's say the first way of a comparison. We can go back. I can even choose here from Microsoft Foundry, choosing GPT 4.1 Mini Let Be. I can open it here, again the same, and then additionally we have here the parameters and the parameters to configure. Additionally, we can ask here if we are not sure for which one to use, which model to use, despite the leaderboard benchmarks in the Foundry. Additionally, GitHub Copilot here in agent mode, especially Cloud Sonnet 4.5, it helps us like with which agent to use. We can ask a question there, but we can do like, I want travel planner. I am not sure which model to use. Please compare models and show their latency, cost, accuracy for such a scenario. And this can be helpful, and this is done. But for this case, going for enterprise, I would suggest going in the Foundry, going in the in the Microsoft Foundry here, where in the Microsoft Foundry we have the models. We can select the project. We have also here the model catalog. We have a leaderboard. We have a leaderboard, which is done by datasets of Microsoft. Like I want the quality, the best at the moment, the safest. Or we can go back. We have even the option for comparing models, where we can add multiple models, and we can select on this side, like I want to compare accuracy by cost. And let me check what I did. Accuracy, cost, can't compare that. Let me check. Removing a model. Quality index with latency. Cost with latency. This is more helpful, more real, I would say, even just doing this in the tool, and that is helpful. But this is again more enterprise. Coming back to our tool, and what we see here, yes, we got a table, we got details. Again, very helpful to select a model for starting. And okay, for this demonstration, it's not important which of one of these will be used, but again, just giving idea how to start and what are the features here. Coming back here, despite the model catalog, we saw on the model playground. And after we have selected the model, then we can continue with the agents. We can continue with the agents, and here we can create a new agent. This is the agent builder form. Like what we have, an agent name. I can write here travel agent. We select the model, the thing that we were doing previously. I will select for this case, let be Foundry GPT 4.1 mini. How it knows, because I have the Azure extension, I am already signed it there, and it's already connected with my tenant, with my subscription. When you will install the AI Toolkit, it will indirectly install in this Azure extension if you don't have. And here we give instructions. Let's say I can write instructions like you are traveler assistant that will help people when traveling around the world. I can write with my words, but if I cut this, we see here we have a generate button. If I type writing, it says improve. I will delete everything. I will say generate. It asks me what to generate, and I have this requirement. Based on this, now it will use an LLM, will create a better, much better instructions. We can recheck, we can then edit the same. Additionally, we can have variables. We can have variables where in the instructions there we add something like with double brackets as is written here. And we have tools, connected agents, but let it be like this. And let me just save the version. It will be version 1. I saved. It appeared on the left side. And if I go now here, I can ask like, I am in Stockholm. Suggest me places to visit. Okay, it works, but this now it uses the LLM knowledge, and it gives from that LLM knowledge what we want to create this more real, more dynamic. That's why, like for every agent, we will need to introduce here tools. While we are here, I can clear all messages. And while we are here, if I go even here for a new agent, when creating a new agent, if you notice on the right side, we can get started with some already existing MCP servers. I will just add here MCP servers for web. it will use the web MCP server. What we'll do, it said, please navigate to example.com, take a screenshot. We are waiting here. It is working, as you see. It's able to open even a browser, to search through web, and we see that all this is done even through Playwright. Why Playwright? Because in my MCP here, if I go in MCPs, we have MCPs already installed, like Playwright, Microsoft Docs, which I have. From where are they? We have here option like browse more MCPs. Like everyone, it gets all these connections here. I have already installed MCP Playwright for me, but additionally, I can add a Microsoft Docs, I can add a name, and that will be, let's say, here for me. What we see, we have some starting steps with MCP, even here with Playground that is able even to serve through internet. In our case, in Traveler Agent, we can add in that web scraping, but we will try other options. We will go in MCP server, and what we see, we have MCP server in AI Toolkit, and also we have use tools edit in Visual Studio Code. I am clicking that tools in Visual Studio Code. We see Azure things. These are not helpful for me, but while we are here, we have here the help for MCP workflow. Like we can add an MCP server, or we can create a new MCP. Let me create a new one. We have here templates. I will choose a Python, location, MCP server name. MCP server name, let will be here conferences MCP. Enter. What it does, it creates a new project. It creates a new project with starting code, where here we have the server. It has some mock data. What we want this to use in our agent. What we can do here in the agent, I will say update this MCP server to include some mock data about AI conferences. It's enough. I am asking for help, this file to be updated, and then the same. We will start in debug mode and we will connect from the agent. Just waiting here some seconds to get some more data. It means we are starting with MCP server with the default project, like all the files are in place. We have here even a README file. We have even a README file which guides us through all this project. And the server here is using the fast MCP. We are just waiting briefly, and then in the agent, we will add an MCP. We will select this local one. It added some mock data. Okay, we are happy with it. And then in this project, I will go here, debug in agent builder, start. I'm starting it. Okay, it's still starting. Attach, yes. Already debugging mode. Cancel. I have multiple instances started of Visual Studio Code. Let me see. And now where is our agent? Our agent, if we go in the toolkit, it is here in the agents. It was Traveler agent. It's this one, yes. And then now we will go in the tools, MCP server, and we see here a local server conferences MCP. Add that. What we want to connect to all these four. Perfect. Okay. Edit them. And additionally, in the instructions, I will improve. Like always ask for available time to visit, distance, and travel option. Improving. Okay. We improved instructions to get like more questions at the beginning, like how many hours you have available. I have 5 hours, the distance, and then based on that to be more real to give something. Okay, better to save the version 2. Okay, and then here we can test it. I am in Stockholm. I want to attend an AI conference. Let me see. Okay, to help you now, it asks more, like time frame you are available. Today afternoon. Are you looking for physical conference? Nearby center within 2 kilometers distance, and it's enough. What we want to see the tool call, and it's happening now. Do you see? It's calling a local server conferences MCP. It's doing a tool calling. Yes, that is what we wanted, and that is very good. And let's say we have an MCP server, we have an agent, and we want somehow these codes to deploy somewhere or to make it independent from what we are doing here with this visual interface. For this purpose, we have the option for view code. View code, and it asks us, like, do you want Azure AI Inference SDK, Semantic Kernel SDK, or Microsoft Agent Framework? I have to say Microsoft Agent Framework, it's in preview, not very stable version, but it's changing day to day. We can use more stable Azure AI Inference SDK, but for this purpose, we will just show like Microsoft, and we get the full code. We get the full code where we have here some requirements to install agent framework. Then additionally, we can save this as a file, like a save as. We can put here outside of that source name like agent or travel agent.python. And then while being in the file, we can ask here enable local evaluation and tracing, and then this will start to install all those pre-requirements. We will not wait it. What we saw that we created an agent connected with MCP tools, and we can export the code, put somewhere, make container, integrate somewhere. That is totally flexible. But while we are here, we see that even we can create like multi-agent system somehow. That's the option with connected agents. Everything in my laptop, nothing outside. Connected agents, I can choose here from the existing on the left side. I can say, okay, use this tool when asked for laptops, just some dummy options, and additionally, allocation agent service. Use this tool for finding location coordinates. Somehow like that, we edit tools, saving, and let me go again in the chat. Like I am in the center of Stockholm. I want to buy a laptop here nearby. Entering. Okay, it asks again, 2,000 euro, Lenovo. Enter. What we see, it asks product search agent, the agent that we added on the left side. It connects there, and with this we simulate that connected agents or multi-agent scenario. Okay, and here we are in the Visual Studio Code that was opened for the MCP server. It doesn't mean anything, but I can go back in the previous where we started. What I want also to show here that even we have that more advanced things for model conversion, fine-tuning to make the model, let's say, more prepared for local usage, profiling. What I want to show that we have even the option for evaluation. For evaluation, I can jump where we were here, yes. And what we see, we have evaluation, and it says prepare a data set. Like to prepare a data set, I will not do, but I have a help, generate data. Generate 3 rows. We can even generation logic we can write, and we can generate automatically this data for us. Okay, generate. Perfect. And then here we have the option to add evaluations. I want to evaluate similarity, coherence. Okay. And then which model I want to use? Let be GPT, this one from Foundry. Okay. And we have all in place. We have all in place. And here we can start this, let's say, automatic evaluation. Then we can even control them manually. And if I go in evaluations, I already have here completed one. Do not wait. Like depending on what evaluations we choose, we have all these details here. And additionally, we can use other tools to see this. It's helpful. Do not start from zero. It's helpful. Otherwise, on the right side, we see that for the project we created here for the MCP and the edit agent, I asked for local evaluation. It did the whole chain, like test data, evaluate by, evaluation guide. We have everything also in code if we want to go through that way. Coming back, I want to make easier. Same is for tracing, like we enable through GitHub Copilot. We need to start getting collection here. I will jump here through this help, like create agent with GitHub Copilot. Clicking it, we have tools in GitHub Copilot which are ideal for creating agents. We have a starting, we can modify, and within a minute we can have directly agent in a code. As you see, it's using agent code best practices. Additionally, for tracing, we wrote their prompt, but we have end here more specific by best practices to add a tracing, and the same for evaluation framework. What I want to show that even if you don't have knowledge, even if you are a starter with agents, as you see this tool with the help of GitHub Copilot, it enables all these here just within a clicks, and then it will explain to us, we can guide it, it can guide us, and in such pair working here, we can learn more. Okay, these were also the features, and I wanted something else to show here. I want something else to show here, something newer. What I want to show while we are here in the agent mode. Let me go first. New chat. While we are here, we have something called AI Agent Expert. What it says, expert in streamlining and enhancing the development of AI agent applications, and what we did until now. If we choose this mode in GitHub Copilot, we get more expert mode for working with agent. And I encourage you to try. And this way of working, I just asked here, like, what can you help me? It says I can build agentic applications, generate code for single multi-agent workflows, what we did mostly, now this can do with the single steps. Like it can continue. We can ask like, I want an traveler agent, including MCP tool for AI events. It's enough just for demo. You need to write more. Just let's see how this works. And within 2, 3, 5 minutes, it creates everything. It creates the project for agent, the project for MCP, the explanation. Very powerful. I will help you to create that. Still thinking, getting agent code generation best practices, AI model guidance. We can, as you see here, set up tracing, evaluation to do for here, continuing in a cloud, like very perfect options, which are just within the development tool that you use every day. Okay, we will not wait it, but just I showed as a feature that I encourage you to try it. While we are here, I can just come into Microsoft Foundry tool. What we see here, we see models just from Foundry. This is a project in Foundry. We see agents, declarative and hosted. Hosted are the new, declarative, no option to create here. And if I go in classic, here we can create those classic or declarative agents, which means through user interface. But the version 2 now, it's just through code. If I go hosted agent, it just goes through code. As you see, I have 2 classic agents. And if I go now to see them in the portal, those, if I want to see this in the portal, let me go in agents. I am in a classic portal, be careful. In the classic portal, we can see them. Those 2 from Visual Studio Code, agent portal, new agent are here. But if we switch to new Foundry, be careful, we are in the new Foundry, in the build, agents, no agents. Because these are treated like V2 agents. And if I want to see those agents which I had, there is here bringing existing agents like classic agents. And those classic agents, I can now upgrade through this option here to be V2 agents, then will be available in Microsoft Foundry V2, called V2. And now here in agents, yes, we see that upgraded agent. Okay, just to quickly recap with the following slides. Evaluation. For the evaluation, it's like iterative process where we compare side by side, like a recommendation here. It is to change one variable at a time, to change the model, to evaluate against same criteria. We have there many options to evaluate. I can just briefly come again in the tool, like when we are in the AI toolkit here, in evaluations, we can even create evaluator. We can create even evaluator, but also we can see what evaluators are already there. And this is very helpful. Oops. Additionally, what we did until now, we used AI Toolkit for model, for MCP servers, yes. We can use GitHub Copilot for connecting there with the application, making them together, or we use even for helping us now for creating agents. When we are ready, then we can use GitHub Copilot for Azure to move this in the cloud, like in the Foundry, or even making a container applications. I have also an article in my LinkedIn profile, like deploying from local to cloud, like the things we discussed similarly, like using Visual Studio Code with extensions, where after we have ready, we use Copilot agent mode to make it in an application, like with a front end, with a back end, the container. And then we use GitHub Copilot for Azure for moving this to Azure. Why this? because most of the developers are not very familiar with Azure, and using this Copilot is very, very helpful. To use this Azure Copilot, we just need to write @Azure, and then it can explain to us, it can give options, it can create infrastructure as a code, and everything can be just sent to cloud from staying here into Visual Studio Code. Like I strongly encourage those developers who are not very familiar with Azure, you can learn Azure, you can be guided very successfully by using the GitHub Copilot for Azure. Until once we have all this ready, then we have here just a checklist I recommend before going to real users, and like start with agent behavior, like the agent to have a clear role, to produce uh, structured, predictable outputs. Then check the tools you use, allow least privilege principles, especially if you are working with a banks. Check if they have any Microsoft purview to have a detailed control governance there. Evaluation, mandatory, and you need to check with iteration, with regression checks for quality improvements. Observability, mandatory, tracing mandatory. For safety and governance, if you are going to Foundry, check, use the guardrails there, content filters, and then you can also check plan for deployment options, cost options, to put there any rate limit, any cost control, to control scaling, safety, and additionally, if you need to use like API management, SAI gateway, many other options which are when going to cloud. What we did until now, we were focused just in the local preparation of a pilot idea, experimentation with no infrastructure, no cost, just in our laptop. And we did all that with the help of internet and GitHub Copilot, which guided us for like everything. Okay, this was the presentation part. I tried in this more than 50 minutes, I see, to recap, to put together all these features which are there, to give an idea how you can start to build an agentic AI today, easier than any day before, with the help of AI. As you see, we need just to drive it, to direct it, and then we will arrive to the destination. Normally, again, we have that responsibility to be a responsible AI and to be governed, observable, and compliant with all other requirements of the industry and of the agent. Thank you. We can continue with any questions.
Yeah, thank you so much. This has been a really interesting presentation, I think.
Yes, it is. Thank you so much, Fisnik. It was I like the way you delivered the theory part, the important concepts, and then the code demo as well. And we have a very like big, I mean, huge, good number of live audience just like focusing. I think they've been quiet asking questions, just like me and Håkan in the backstage also learning, but. I do have one question in mind, but I'll let Håkan take his question if he has anything that he wants to bring up live also, because I think discussion over this is good to have, even though we're a bit over time, but I think it's good. Do you have anything, Håkan?
Yes, I think one thing that might come up is here that, these different models, they evolve very fast, and there are new versions, and some versions get to legacy. They will not work any longer. So do you have any advice on how we can work with that? How do we know if a model is updated, and can we sort of do a bulk update for our agents?
The list of models changed. I mentioned as a more formal. I mentioned while we are in Foundry, comparing agents in this Foundry leaderboard, which is more accurate, I would say. But even every model that will come within 1 to 2 days, it appears in Visual Studio Code also, which is like you have that in real time for experimentation, which doesn't matter anything. Selecting the base model, I would say these two options, leaderboard and comparison, these are the best at the moment, which can help you, guide you, like even cost, quality, accuracy. This would be the choice, the answer for sure. Everyone to try, please.
Thank you.
Okay, that's good. I was about to ask actually two questions. One of them was related to costs because it's one of the challenges, of course. Also, when you put, I mean, locally it's no worries, but when you put it to the real environment or even non-prod environment in Azure or Foundry, then it starts sticking the money. So it's good that there's that option for cost as well. Are you done with your question, Håkon?
Oh, yes.
Yeah, follow-ups?
No.
Yeah, no questions from the audience. I really encourage you to ask questions, but if you're shy, feel free to join our after session fika on the Bitly linked. We will share again, but we do have one comment. Thank you so much for organizing this, having so many details. And probably, Fisnik, you're willing to share the presentation copy as well later
Sure.
to those that missed it, or you can also watch this session recorded. I have one question before we finalize our event and then show a feedback QR. I saw that Sessionize has a new feature where you can kind of like leave feedback for the sessions, and it's been great. One question for you, Fisnik. This is from my for me. General questions is like with the perspective of developer, like organization or anybody that's trying to adopt agentic AI. What do you think is how would like take the best approach in identifying if a use case or a problem is ideal to be developed with agentic AI? Because we know how it is, right? Sometimes one problem suits this, but the other problem doesn't suit that. So what's your approach based on what you have learned on developing with this?
For agentic solutions, so first those which are time consuming, and the most successful that we have seen in different industries companies are those which aren't fully autonomous, but at least need a human in the loop. Those
Exactly, yes.
two as a first things to try automating and making easier for people to be focused on other things and to be more creative to push the business towards.
Yes, I know the trust also. That's the responsible AI, and also having this collaboration between us human, which should be in the loop sometimes, depending on the approval process, and also letting AI help us also with the automated part. It's a very interesting topic on that. That's all. Thank you for answering my question. And we also have a thank you from another audience watcher, Laddie. Thank you,
Thank you.
Fisnik and
Thank you.
team. Awesome presentation. Thanks, everyone. And did you have anything else, by the way, before we kind of show the some QR codes and finalize the session? Do you have
I
any
just want
contact?
to add. I want just to add something about the cost.
Cost, yeah, because
Yes,
I had a thought on that.
cost in production. There is a PTU in Microsoft Foundry, provision throughput unit, like reserved instances that you can buy for a longer period. It's much cheaper. With that, you have guaranteed latency. And it's hard to know how much PTU you need because it's like a new metric, but you can start within 1-2 hours to do some load tests to see in metrics, like to see how many PTUs you use. Based on that, then you can purchase for a longer period time. Because guessing I need 100 PTUs, 10 PTUs, it's not ideal, and it's not even in cheap. But this way you will get a realistic scenario for you by trying testing in 1-2 hours and then trying to purchase, or in more hours to try to test. It's more expensive, yes, but you do it once and then you buy for a longer period.
That's a good advice on that, because I know, I mean, using Azure when you're solutioning a solution on Azure and choosing the services, then you have the Azure pricing calculator, the cost management, but we're inside we're inside the service itself, and we're talking to different models, which can be large or open source. So that's very good add-on. Anything else to add, Håkan? You're also in this space on Azure AI, on your perspective.
No, I think in that case we can take it in the Zoom meeting.
Yes, okay, that's good. Any last contact info you want to share, Fisnik, engagement initiatives that you want to share to our community or watchers?
Contact info I have here my LinkedIn account. I try to be active on LinkedIn also on events. In February I will be also presenter in 2 community events. Also I continue let's say in Microsoft events being a speaker, and that is the plan for the next month.
That's great. Great presentation and session. We appreciate it. And to those who wants to leave feedback, it only takes 1 minute of your time to appreciate our speaker Fisnik today. Feel free to leave feedback. It's for us, the speaker, and how we can improve our session. So feel free to scan this. I also shared the link to this on our live stream chat, and also for the after session fika, we have it like 15-20 minutes if you have time to spare, and sit with us with your favorite drink, warm or cold, to just continue the conversation there if you have time. So feel free to do the bit.ly link or save the QR code. And we look forward to see you again in 2 weeks for our next session. Anything else, Håkan, Fisnik?
No, that's all from my side. Thanks.
All right. Thank you so much, everybody, for your time with us this weekend. And thank you, Fisnik, for devoting your time, sharing your knowledge, and also to Håkan for co-hosting this with me. And I wish everyone, all of us, a happy weekend to your home or wherever you're watching this. Have a great day. Thanks. Bye.
Thanks, you.